So you're exactly right. We want to change this to exponential form. So remember one thing that I said, when you're dealing with logs, if ever you're like, I do not know what to do with this log, whether it's to graph it or solve it or whatever, see if you can change it to exponential form. And usually from there, students are like, oh, now I know what to do, right? I spelled exponential wrong, sorry. So 2 to the 3rd power, right? We're doing 2 to this power equals all of that, the 4x minus 8, right? 2 to the 3rd power is 8, and now we're just solving this for x. And then when I do
made that way harder than I needed to on the test, on the quiz.
And that usually happens, right? You're just like, oh my goodness, why didn't I, remember that that's what I needed to do? But that's what, I want you to, really, take note of the ones that you are struggling with and, put a little star by them or something so you remember, okay, I need to go back. I need to remember that I need to change these type into exponential form before I can solve it. That will make it a lot easier. Okay? Okay, what about the next one? Right, well, so when we have something like this, so let me keep that there in case some of you need to still see that work. Right, so when we have these multiplied together, we are just foiling these, right? And so I'll do 5 times 3 is 15. 5 times 2i is 10i. And I get negative 18i. And then negative 12i squared, right? And then remember, the one thing that you need to remember with imaginary numbers, well, there's actually 2 things, right? The square root of negative 1 is I, and I squared is negative 1. So wherever we see an I squared, we're going to replace it with a negative 1 so that we can simplify this more. So place of this I squared, right, negative 1 is going to go in place there, and then that really changes that to a positive, right? So I have my 15 plus 12 is 27, and then I can combine my i's together, and that will give me negative 8i. And then I want to make sure I put it in that form, a plus bi, right? So the real number first, and then the imaginary number second, just like this. Questions on that?
So you took the I squared and turned it into a negative 1, and then you just multiplied it by the 12 and made it a positive.
Am I exactly that right? Yep, that's exactly right. So I took that negative, times it by negative 1, which gave me really a positive 12. Right, and then I added that.
Perfect.
Does that make sense?
I just wanted to make sure I saw that.
Yep, you did. That's exactly right. Okay, so just to make sure you remember that. These would be some things that I would say make sure you put on your little formula sheet that you make up, right? Is that, the I stuff. So you make sure that you remember that. Now, I was going to show you something. Where do you find the final exam information? Let me pull this over here for just a minute, just to make sure. Remember that in the final exam module, there's this final exam information for students, and it has a ton of things in here. One of which is this objective review for 2019, so that's the one that we want to look at the most, but there's one from 2017 that you can use, and there's also these old practice finals as well that you could go through, right, which we're going through one like that. Where did it go? Didn't it open? Oh, it's down here. Okay, so, but you'll notice on the objective review, they actually give you some important things to know. And so if you feel like these are some of the things that you might forget about, I would write the ones that you need to know on your sheet of paper that you're going to be bringing in and using on the final exam. So just know this is here, and these are the things that we suggest, like, you know, in the past that students have memorized, right? But you'll be able to use them on the test. So if you don't have some of these memorized, write it down, put those down on your sheet of paper. Remember, you only get one sheet, one side, right? And you'll be uploading that with your work also. Okay, let's look at the next one here. So it says solve by completing the square or using the quadratic formula. Remember, completing the square can only be done if this leading coefficient is a 1. So we could use that on here, but I think most students would probably choose to use the quadratic formula, and either way is fine on that.
So is the only way to know whether you should do completing the square or the quadratic formula just based off of the positive number 1 at the beginning?
Yeah, if that leading coefficient is anything other than 1, right, then you cannot use completing the square. You have to go to the quadratic formula. Right? And we'll do completing the square in just a minute when we do like one of the circle ones. So let's just do the quadratic formula on this. Remember, that's x equals, and we're going to use positive 2 plus or minus the square root of negative 2 all squared minus 4 times 1, because that's our leading coefficient, that's our a, right, times c, which is negative 12, all over 2 times 1. And then you just need to simplify this. Right, so let's try that. Let me give you a minute. Simplify this on using your calculator. See what you come up with.
I think the part that I get stuck on this is knowing when to stop and when not to stop. So I got 2 plus or minus 2 the square root of 13 all over 2. So then I don't know when to stop.
So
like,
you need to keep going from there. And notice how I wrote it, you know, the 2 underneath both of these. So it was a little bit easier to see that what I'm really doing is 2 divided by 2 is 1. And then 2 divided by 2 divided by 2 is 1. So there's really like a 1 out in front of us, but we don't need to put that down, right? And so, yeah, so you have to simplify it as much as you can. So that's a good question. And then sometimes, so this would be the exact answer, but maybe it might ask you to round to the, you know, the nearest, you know, 10th or something like that. And so you could, you know, put this into your calculator, that 2 plus the square root of 52. And then I'd hit equals, change it to a decimal, and then divide that by 2. So I kind of do it in, you know, get the top in there, press equals, and then divide by 2, and then press equals again. Just to make sure I have all of those digits in there. And so that would be 4.6 if we rounded it to the nearest whole number. This is the plus one, right? If I did 2 plus that. And then the other one, let's see, if I did 2 minus the square root of 52, and then divide that by 2 also, I ended up with negative 2.6. Okay, let's see if that's what you guys kind of came up with there. So it just depends on how they want your answer, right? So yeah, so Jordan wrote it down, you know, with the decimal, but it'll tell you which way it wants it, either as a decimal, but if it says it wants the exact answer, then you need to make sure you remember that that means radical form, but it needs to be simplified radical form. Okay. And again, you know, things to make sure that you're thinking of, what do I want to put on that sheet that I'm going to take into the test, right? All right, so on number 5, remember how we talked about there was like a little shortcut way that we talked about doing these? And so if it asks you to figure out, you know, the time that it takes to work together, then you did the A times B over A plus B. But if it wanted you to figure out how long it took one of them to work alone, then you did A times B divided by A minus B. All right, so this was just kind of a little shortcut way to do this, which I think is helpful. But if we're reading through this, so working together, 2 copy machines can finish a job in 3 minutes. The slower copier can finish the job in 12 minutes. How many minutes would it take for the faster copier to finish the job? All right, so we want this one where we're working alone because we're trying to figure out how long does it take the faster copier to finish the job if they did it alone. Right? And so I want to do my A and B. Well, what are my A and B? Well, we always want our A to be the larger number. So I would just say, okay, A is going to equal my 12, and B is going to equal my 3. And then I can just plug it into that formula. So 12 times 3 over 12 minus 3. So 36 divided by 9 gives us 4 minutes. For the faster copier. And that makes sense, right? Because it takes them, you know, 3 minutes together, right? So it should be a number that's between 3 and 12. Right, so 4 minutes. Any questions there? Make sure you're speaking up if you have a question, or type it into the chat. Like, I want to make sure this is helpful for you.
So the formula is A times B over A plus B for together, and then same thing, only A minus B.
On the bottom. Yep.
Okay.
Yep.
And we want A to be the bigger number.
You need A always to be the bigger number. Yep.
Okay.
Otherwise, you'd come up with a negative.
Today.
You'd come up with a negative 4 minutes on this if you didn't do that, and so that would be really bad, right? You can't have a negative 4 there. So, yep, that's right. Okay, so the next one is talking about longer synthetic division, and we can use synthetic division on this because our leading coefficient is 1 and our exponent is 1. Right? So those are the things that we're looking for. So on the denominator, leading coefficient is 1, exponent is 1. And if we can do that, then we can use synthetic. Okay, and so remember, I look at the bottom, the x minus 3, and I need to do, you know, think what x value would make that be 0, and that would be negative 3. Or sometimes students just think of it's the opposite of that, right? And that's what goes in your little box up here. And then you need to write the coefficients down, right? And make sure that everybody is accounted for, meaning that we got an x cubed terms, x squared term, x, and 6, right? So if there was one of those missing, we'd have to put a 0 in there to hold the place open. But we don't have any missing, so we'll put those down. So 4, 9, negative 7, and 6. Right? And then remember, this is the way we solve this. So the first thing that we do is we bring down that first number. Right? So just bring down 4. Then multiply.
What is that -3 for again?
Pardon me?
Where'd that -3 come
You look
from?
on the denominator, right? And you're thinking, what x value would make the bottom 0?
Okay.
And so then so bring down the 4, and then we'll take that 4, multiply it by the -3, so that's going to give me -12. Right? And then let me give you just a minute to finish this out. Kind of started it there for you, but let's see if we can get the rest of that. Okay, so you should have gotten 4x squared minus 3x plus 2. It's a remainder of 0. But remember, if there was a remainder there, you'd put plus whatever that remainder is over your x plus 3. Right? So whatever that remainder is needs to be written in that form.
Can we just go over that really quickly?
Yeah,
Sorry. So
that's fine.
I don't remember exactly how to do it.
So after we bring the 4 straight down, right, multiply that number on the bottom by the number in the box. And then put it under the 9. Then we combine those together. 9 minus 12 is -3. And then you're going to start it again. -3 times -3 is +9. Combine those together. You'll get +2. 2 times -3 is -6. Combine those together and we get 0. And then remember, since we started with an x to the 3rd power, right, and it's dividing by x, right, x to the 3rd divided by x is x squared. So that's where we're going to start this out, is just 1 less than what we started with. So x squared, and then the x, and then the constant term. And then whatever your last one is here, this is always the remainder. It just happened to be on this one, it was a remainder of 0, but that definitely could be something different. And so then make sure you write that as a fraction, whatever the remainder is, over your denominator in the original. Okay. All right, let's take a look at this one. So in this one we have, we want to solve this square root. And so you always want to make sure that your square root is by itself first. Right? So that means I need to add my 3 over so I can get my square root by itself. And now that it's by itself, now I need to ask myself, okay, how do I undo square rooting something, right? Because whenever there's a way to do something in math, there's always a way to undo it. So so raise to the power of 2 or square both sides, right? So then that square root and that square, they cancel each other out. That's the whole reason why we're squaring it, to get rid of that square root. So that leaves me with just 14 minus 2x, right, on the left side. And on the right side, I just need to square that 2, which will give me 4. And now I'm just solving for x. So let me subtract my 14 over, which will give me -2x equals -10. And then divide by -2. Right, so x equals 5 on that one. And it's always a good idea to check your work on this. So check your answers whenever you're dealing with square roots. So let's do that just really quick over here just to make sure everybody remembers how to do that, right? So if we check the work, we're just putting 5 in place of x in my original question. So I've got square root of 14 minus 2 times 5, and then on the outside of the square root, minus 3 equals negative 1. So I'm trying to make sure this is a true statement, right? So 14 minus 10 gives me just square root of 4, and then minus 3 equals negative 1. Square root of 4 is 2. 2 minus 3 is negative 1. So this does check out. This is a good solution. Okay, so but make sure to check your answers, right? Always, I mean, on any of the ones that say solve, if you have, time before you hit submit and end on the test, go back and check your answers. I highly recommend it. If you have any time left over, you can always check these ones that say solve. There's no reason to miss any of those from like small mistakes or something, because you can do it. Okay, you can just plug those back in. Okay. All right, so this one is a circle problem, right? It's given to us in general form, but we need to change it to standard form to be able to figure out what the center and radius are. Right? So that's really what it's asking us to do, is we need to change it to standard form. And to do that, you're going to complete the square, right? Is what you need to use on this. So I'm going to write this out. This is black actually here. So this is what it says originally, right? I've got my x squared plus 6x. So I need my x's together plus blank, right? Because I'm trying to make this into a perfect square trinomial. That's the whole thing that I'm doing with complete the square. Then I need to put my y's together. So plus y squared minus 2y. And then this negative 14 there, actually I should start by adding that over to the other side first, because I don't want that on the left-hand side. I just want the stuff that I'm doing with completing the square there. Okay, but if I add something, change the color on these a little bit, right? So if I add something to one side, I need to add that same number to the other side. And I did that twice, right? So I need to add those over, right? And then to figure these out, remember you're doing half of that middle term, so 6 divided by 2, change this to purple again. All right, so 6 divided by 2 is 3, squared is 9. All right, so 9 is the number I need to put in the blank on that side and on this side. Anybody remembering this? Then with the next one, right, so again, I'm taking that negative 2. Whoops, let me put that actually in a different color. Sure. So I'm taking negative 2, dividing it by 2, and then squaring it. Right, so negative 1 all squared is positive 1. So I'm going to put 1 in both of those blanks. Okay. And then how do I write this first part out? How do I write that in the factored form? Anybody remember? No, but
X plus 3 minus, or all raised to the second power.
Right, I'm taking whatever my number is that I find half of, that's always going to be the number that's there, right? So that means that my other one is going to be y minus 1, right? Because half of negative 2 is a negative 1. That's why it's a negative 1 there, all squared. And then that's going to equal 14 plus 9 plus 1. Well, 9 plus 1 is 10, plus 14 is 24. Okay? So then what would my center be? Because it's asking for the center and the radius. What is the center?
-1.
-3, positive 1.
-3, positive 1. And then what's the radius?
I'm guessing. Is it square root of 24?
It is, but can that square root of 24 be simplified more, right? Because we always want to make sure that we simplify any square roots, right? So 24 is 4 times 6. Right, breaking these down, it looks like, yep, there's a 2 that I can take out, right? So that's going to give me, if I wrote it down, that would be 2 times 2 times 2 times 3. 2 gets to come out, so that's 2 square root of 6. And so that's how I'd want to write my answer, making sure that I always simplify, right, that radical. Otherwise, you're going to be missing some points on that. Okay. Awesome. Good job, guys. Okay. And then if it asked you to graph something like this, they would make the radius come out nice and neat, right? So that they've done that before on final exams where they've asked you to graph it also, but it would probably be like, this would end up being 25 or something instead of 24, right? And then the radius of that would be 5, and so that would be easy to graph, like I said. Okay. All right, let's keep going here. I want to make sure I can get through as many of these as possible. I hope you're finding this helpful and remembering some of these things. Some of it's, newer in your mind, and some is from a while back. So
I feel like synthetic division was like 7 years ago.
I know. And like when we get to the one where we're solving 3 equations with 3 variables, sometimes people are like, oh yeah, I totally forgot about those. So, right, so it's just a matter of goodness. Okay, so finding the inverse function, right? There's 4 steps that you take to find this inverse function. So first, change your f of x to y. So I'm just going to rewrite this as y equals 3x plus 8. Right? And then with inverse functions, you're switching the x and y. So I'm literally switching these places. So x equals 3y plus 8. Right? And then I want to solve it for y. Okay, so I'm going to write these steps over here too, right? So I'm going to replace f of x with y. And then switch your x and y. And then solve for y. Okay, and then when you write your answer down, and this is actually on the last, when I was looking through some of these, and I apologize I didn't get all of these corrected for you guys today, but on the week 11 review, it had a question like this. In fact, I think it might even be the same one, which is kind of funny, right? Except if you did it on using the Proctorio stuff, you got probably something a little bit different. But some people just forgot how to do it completely and left it blank, and other people just forgot to write it back in the form showing that it was the inverse function. So once you say y equals all of this stuff, right, the last step is you've got to change, to that and show it's like that inverse function form. So the inverse of f of x is x minus 8 over 3. And it actually doesn't matter if you write it like this or if you separate it out like this. Right? They'll accept it both ways. Okay. All right, so that's the inverse function stuff. All right.
Can you go back up for 1 second? Sorry, I just need that last step.
Yeah, just make sure you change the y. Whoops, change y. Right? So you just have to write it in that form that shows that it's the inverse. So that f to the negative 1 power of x tells us that it's the inverse function.
Thank you.
Okay, and I might not work all this one out because we've done some kind of like it already, right? Because it's saying, you know, what is the maximum temperature, and then, or sorry, what is the hours until it reaches the maximum temperature, and then what is the maximum temperature, right? And so remember, whenever you're trying to find a max or a min, right, you want to find the vertex. Right? And the vertex on this, right, so, and it tells you in here, right, what T stands for. Right, so T is the hours, and then F of T is the temperature in Fahrenheit. So this is the temperature, right, in degrees in Fahrenheit. So just, you know, making sure you know which one's which, so that when it asks you, you know, to put your answers, because it's going to give you little blanks, right, just like you've had on your quizzes and your tests and stuff. So what's their maximum temperature? There's a blank there. What's, sorry, the hours to the at the maximum temperature, and then what is the maximum temperature? Because sometimes students accidentally switch those answers and put them in the wrong blank. Okay, but remember to do that. You're just finding the vertex. So make sure you have that vertex formula written down. Right, that negative b over 2a. All right, and I think I'm going to skip number 11 also there, because there's just some other ones that I think are more difficult that I want to get to. All right, what about one like this? So when it asks you to subtract these two, right, in order to subtract fractions, we have to have a common denominator. And so to find our common denominator, remember that we said, you know, I mean, if you had something like, you know, 3 over 4 plus 5 over 7, to get a common denominator there, you could just multiply those two numbers together, right? The same thing happens here. Is we're just, our common denominator is going to be x plus 5 times x plus 2. Okay, so I'm going to write this down with the common denominator. But then I need to look here and say, okay, well, what is this first fraction missing, right? It has the x plus 5, but it needs the x minus 2 part. And so I need to multiply that on the top and the bottom. Right? On my second fraction, it already has that x minus 2 part, but it needs the x plus 5 part. So I need to multiply that on top and bottom. And so then I need to distribute these through, but I want to caution you on one thing here. All right, so see this minus here? A lot of times this minus sign gets overlooked. So if it's a minus like that, I would change it to plus a negative 5, so that you're really distributing a negative 5 through there, so you don't forget about that negative there. Okay? Because sometimes people will remember to put it through the first one, but not the second one. And that changes your answer completely. That negative 5 has to be distributed to both, right? And over here, our 4 needs to be distributed to both. So I'll have 4x minus 8 plus negative 5x minus 25. And then I just need to get my terms combined together, right? So 4x minus 5x is negative x, and negative 8 minus 25, it's going to give me negative 33. Right. And then I just need to keep my denominator here. But one thing I want to caution you about is, so this top right here can't factor any further, but if it could factor, we'd want to try and factor that and see if it would be able to divide out with something on the bottom. All right, so you always want to look to simplify for the very last step. All right, and if it can't, then that's all you can do with it. Does that make sense? So on these, all right, you have to get a common denominator. You cannot just kill the denominators off. Okay, so let's see, I'm going to mute somebody that is who. All right, so if it were an equation, so I'm going to skip down to that one right now, and we'll come back to some of these other ones, but because I want to compare it to something like number 16 here, right? So this one is an equation, and with equations, you can kill the denominator, right? So I'm going to put since, oh man, I'm struggling. Since it is an equation, you can kill the denominator. Okay, but we couldn't do that on that last one because it was an equation. It didn't start with an equal sign in it. Okay, if it starts with that, then we can. All right, so on this one, all right, we want to start by factoring our denominator here because that's going to help us find what our LCD is. So if I look to factor this, t times t is t squared. What times what is negative 3? That adds to be positive 2. Well, it's going to be 3 and 1. 3 needs to be positive. T needs to be negative, right? And so it actually ends up being those same things that we have on the other ones, right? Which a lot of times it does, right? So our LCD is exactly that, the t plus 3 times t minus 1. So I'm going to write down over here. So I have this t over t minus 1, but I want to multiply that by the LCD, which is t plus 3 times t minus 1. Okay, I'm going to multiply everything by that LCD. My next part is that minus 2, but again, I'm going to change this to add a negative 2, so I don't forget about that little subtract sign. Like I said, that can be a real issue. Right? So negative 2 over t plus 3. So t plus 3 times t minus 1. And then that's going to equal 8 over, whoops, and then multiply all of that by the LCD. All right, and some of you have taken, shortcuts on this and stuff, and as long as you understand why the shortcut works, that's totally fine to do. But so what I want you to see here, right, is we're killing the denominator. So I can see that in my first fraction, I've got a t minus 1 on the bottom. That's going to cancel out with that t minus 1 on the top. In the second fraction, I've got a t minus 3 on the bottom. That will cancel out with that t plus 3 on the top. Do you see t plus 3? Right, in both places. And then on the last fraction, both of those on the denominator, right, get canceled out. And so what I'm left with is t times t plus 3 plus negative 2 times t minus 1 equals 8. And then I'm just solving it from here, right? So I need to distribute that t through on this one. So So I get t squared plus 3t. Distribute my negative 2 through, so minus 2t plus 2 equals 8. And then want you to keep kind of going with this. Oops, here. All right, clear back up there. Okay, but I want you to try and solve this from here, right? How do I solve it the rest of the way from here? Okay, so see if you guys came up with t equals negative 3 and t equals 2. Right, so the way that we try and solve these is we've got to get everything on one side set equal to 0 and then factor it. But then you need to check your answers, right? So do both of these answers work? So what am I looking for there? Well, remember back at the beginning, right, if I'm looking at this original equation, right, the domain of it, right, t cannot equal 1 because that's going to make my bottom equal 0, and t cannot be negative 3 because that's going to make my bottom equal to 0. So sometimes, you know, students start off by saying, you know, t cannot equal 1, t cannot equal negative 3, right? Just to make sure that they remember those are our excluded values on this. And so negative 3 is not a good solution, right? We only want t equals 2. And if you went to check both of these, right, so if you went back and checked it, you'd see negative 3 doesn't work, but 2 does. But really what you're looking for there in the check is just making sure that the bottom, right, we're not going to be dividing by 0. Does that make sense? You guys remember that? Those excluded values? Questions on that one? Yeah, and I think that is the reason why most people miss this question on the final. It's not, I mean, because this shows up a lot. I mean, obviously it was here. You'll see it. If you look back on some of the other ones, you'll see this type of question on there a lot. And so if it's on there, a lot of times students miss it because they forget to check the answer. So write that down somewhere, right? Make sure that's clear, like that you remember to do that on the final, right? So you don't miss it because of that. All right, let me go back and I want to get, let's go back up here to 14. We skipped over 13, but if you come to the review that I'm going to be doing tonight, we'll go through one like that. I'm just trying to get through ones that, you know, want to make sure kind of get some extra help with. Okay, so remember, on solving the system of equations, let's make sure, jog your memory. It's been a while, right? It's been a minute or two since you've solved the 3 equations with 3 variables, right? So I'm going to first number my first 3 equations, equation 1, 2, and 3, and then I want to choose 2 of the equations and eliminate one of the variables. And as I'm looking through these to decide which ones I want to eliminate, right, what would you guys say would be the best variable to try and eliminate? Okay, Angeline said x. Why x? Right, can you guys see why x would be the best one? Right, we can do 1 and 3 together, and the x's would be eliminated, and we could put 1 and 2 together, and the x's, or sorry, 2 and 3 together, and the x's would be eliminated. So that's why I want to choose those, right? So I'm going to do equations 1 and 3. So equation 1 is x minus 3y plus z equals negative 8. And I would say one of the reasons why students miss these questions too is just not copying down the equations carefully. So just double, triple check that you have all the signs right, that you wrote down what you meant to write down. Okay. So then our x's, right, go away, right? They cancel out there, and we're left with negative 4y plus 3z equals negative 10. And I'm going to call this new equation that I just made equation 4. Okay. Then I want to go back up to the original 3, and I want to get rid of the same variable again. So I see if I choose equation 2 and equation 3, again, my variables will eliminate right away. I don't have to multiply one of them by a number or something to make them eliminate. So I'm just trying to choose the one that's going to be easiest, right? So x plus 5y plus 6z equals negative 10, and negative x minus y plus 2z equals negative 2. So when I add these together, the x's are eliminated again, right, which is what I wanted to have happen, and I'm left with 4y plus 8z equals negative 12. And now I'm going to call this equation 5, right, my new equation there. All right, now what do I want to do? Because sometimes students get to here and they're stuck and they can't remember what to do. So what do we do at this point?
We need to kill off another variable by putting 4 and 5 together.
Right, so let's write down equation 4 and 5, and let's kill another variable, right? So negative 4y plus 3z equals negative 10, and then 4y plus 8z equals negative 12. All right, and they made this one really nice on this final exam. Look at how, you know, now my y's are going to cancel out. But remember, if they didn't cancel out right away, I'd have to multiply either one equation or both equations by something, okay? And I'll do another one tonight at the review this evening where maybe it doesn't work out so nice and neat like this one, but this was off of a final exam, so I'm just showing you. Sometimes, you know, people that write it and make it, you know, are nice about it. Okay, but then we're left with 11z equals negative 22. So if I divide by 11, I get z equals negative 2. Okay, and I want to write my answer as an ordered triple. Remember, that's x, comma, y, comma, z. So I just found z is negative 2, so I'm going to put it in there. Okay, now what do I do next? So I found the...
Put z into one of the equations?
Yeah, so I want to put that -2 either back into equation 4 or equation 5. All right, it looks easiest for me to put it in here, so that's what I'm going to do. So I'll have 4y plus 8 times -2 equals -12. All right, and I'm just solving this for y now. Let's add 16 over. So 4y equals 4. So it looks like y equals 1. All right, so that's going to be the second part of my ordered triple. That's where my 1 goes. And now I still have my x that I need to find. So let's take what I came up with, my y and my z, and now I want to put those back in to one of my original ones. All right, so I'm just going to put it into equation 1. So this goes in place of z, and this goes in place of y. All right, so when I do that, I have x minus 3 times y, which is 1, plus z, which is a -2, right, equals -8. Just put it back into this top equation. So x minus 3 minus 2 equals -8. X minus 5 equals -8. Let's add the 5 over. So x equals -3. And that would be my ordered triple, my answer that I want to have. Okay. All right, what questions do you have on that? So, Jordan likes them. I think it's kind of a fun little game with these too. I really like these a lot. But it's just getting the steps down, right? That is kind of the trickiest on this. And if you can get those down, then you're like, okay, I can do this. And really just kind of think through the steps. Like, what are you doing here, right? Right, I'm choosing, 2 of the 3 equations, eliminating 1 variable. Choosing 2 other equations, eliminate the same variable. Then I take my new equations 4 and 5, eliminate a variable in that. Right, and then I need to just start doing back substitution. So whatever I got for my answer for that variable, put it into equation 4 or 5, figure out what your next variable is, and then when you have 2 variables, you know what 2 variables are, substitute those into one of the original 3 equations. Okay, and find that last one. So, all right, like I said, we'll probably do one of those tonight if you guys want to, if you feel like, okay, I need maybe a little bit more help with some of those. Okay? But, all right, what about solving absolute value inequalities? So first of all, maybe this will ring a bell to you. Remember when we talked about these absolute value inequalities, I told you about greater, right, and less than, right, to help you remember whether you want an or statement or whether you want an and statement. So if it starts out with a greater than or equal to, then you're going to want an or statement. Okay? If it's a less than or equal to, then you're going to write an and statement. So, and this is how we write our statements. So remember, we're going to take these out of the absolute value. So I'm writing 2 different equations here, right? So my first one's going to be 2x minus 3 is greater than or equal to 2, right? And then or, right, because I knew it was an or statement on this. So I'm going to put this or in between here so I remember. Right, or, then my other one is going to be 2x minus 3 is less than or equal to -2. So the important thing here is, remember, you got to change that 2 to a -2. And if I multiplied that by a -1, that flips that inequality the other way. Right? Remember, if you multiply or divide by a negative, that flips the inequality. Okay? And now I have my two statements right here that I need to solve. Right? So let's go ahead and solve each of these separately. So let's add the 3 over. So 2x is greater than or equal to 5. So x is greater than or equal to 5 halves, or that would be the same thing as 2 1/2. Right? Right, so either way is fine. Usually if it is a fraction, I'll just say to leave it in that fraction form, but sometimes changing it to a decimal will help you know where it's on the number line, so that can be helpful. All right, and then let's solve the other one. So let's add the 3 over. So 2x is less than or equal to 1. So x is less than or equal to 1/2. All right, so now I need to take what I have here, what I'm given, and I've got to draw it on a little number line so I can figure out what part of the graph I'm talking about. All right, so I know I'm going to have, here's 1/2, and then 5 halves is 2 1/2, so that's going to be further to the right here. Okay. And then, let's see, I just need to, okay, so if I'm doing this part, the x is greater than or equal to 5 halves. Well, it's going to have a closed-in circle, right, because it has the equal to part, and everything to the right. And then my other one, x is less than 1/2. Sorry, less than or equal to 1/2, so I want a closed-in circle there and everything to the left. Right, so that means that, so since it's an or statement, remember that means I want everything. If it was an and statement, I would want to know where the overlap is. But this isn't an and statement, so I don't care about overlap. I just want to know everything that is on the graph. So that would be from -infinity to 1/2, square bracket, because it was equal to it, union, square bracket, 5 halves to infinity. And that would be my interval notation for my answer. Okay. What about questions on that one? I know sometimes that one's like, oh man, that just seems like forever ago that we did those. All right, but hopefully remembering that greater and less than, that's what you use when you're asked to solve absolute value inequalities.
Do we solve the less than the same way? We split it up?
So with the less than, you would want the overlap, right? And so where do these overlap?
They don't.
So that would be a DNE, does not exist, right? If it was an and statement. Does that make sense? But if they did overlap each other, right? Say that we had, something like this. Say here's 2 and here's 5 or something. And you had, one that went this way, one that went this way. So the overlap would be in between them. Right? So usually the overlap shows up in between. Right? So the and statements, not always, but a lot of times, right? The and statements are in between. And the or statements are going away from each other, like we have in ours. Is that, you're remembering that? And if not, think about, okay, let me go back and try and practice some more of those. Okay, because those definitely show up in that review that we're going to be talking about tonight too. Just the whole, module review for the whole year. Right? You have some like that in there. Okay, let's see, how much time do we have? We only have a few minutes here, so just trying to think. Maybe let me talk about this one, just because I saw on the last test some mistakes that people made, and I want to make sure that you don't make that same mistake on these. Okay, so when you're trying to graph this function, and it asks you to find a few things here on it, right? It wants you to find the vertex, and notice it says write the vertex and intercept in point form, so you need to write them as an ordered pair. So I'm going to go ahead and just write it down this way so I remember. I've got to write these as a point, right, as an ordered pair. And so remember, to find the vertex, right, we're going to use, I mean, you could change this to vertex form, but I would suggest the easier way to go about it is just to remember that x equals negative b over 2a. You can always use that, and I think that causes less mistakes for most people. All right, so negative 8 over 2 times 2, so negative 8 over 4 gives me negative 2. All right, so my x-coordinate is negative 2. Now let's go and find my y-coordinate, right, or what that g of x is. Right. So I'm putting negative 2 in place where I see those x's. So 2 times negative 2 squared plus 8 times negative 2 plus 6. So remember, square first. So negative 2 all squared is positive 4. So 2 times 4 plus 8 times negative 2. Right, so it's going to be negative 16. I'm just trying to simplify this up here, right? And some of you can just put it into your calculator too. All right, so negative 8 plus 6 is going to give me negative 2. So my y is also negative 2. All right, but there's my vertex. So over negative 2, down 2. So that's where my parabola is going to be. Notice that my leading coefficient is positive, so I know it's going to be a right side up parabola. Okay. Now, can somebody tell me, where would the axis of symmetry be? How can I find that axis of symmetry? There's a very easy way to do it, and some of you figured that out. What is that? Yeah, the x, right? So in your vertex formula, right, remember here's your x and here's your y, but whatever your x-coordinate equals, right, is going to be that line, and you need to write this as an equation. And that's where a lot of people miss points on this, is they just put negative 2, but it needs to be an equation, so you need to say x equals negative 2. Because remember, that is this vertical line right here on my graph. Okay, and remember, that's the line in which it's like the line of symmetry of this, so that we, if we folded it over, our parabola over on top of this line, the parabola would land on top of each other. Okay, and then the other thing that it asks for is the y-intercept. Well, the y-intercept is actually, easy to find when it's written in this form. Right? Remember, to find the y-intercept anytime, you're going to let x equal 0 and solve for y. Right? So whether you have, a parabola or a line or whatever graph it is, it doesn't matter. This is always the way you find the y-intercept. So if I let both of those be 0, so let me just write it down here. So if I have y equals 2 times 0 squared plus 8 times 0 plus 6, right? All of this first term goes to 0, and that second term goes to 0, so I'm just left with y equals 6. Okay, and again, some of you missed points on the test because that's what you put, was y equals 6, but it said write it as a point, remember? So we said when x is 0, our y is 6. Okay, and that's the point here, over 0 up 6. And then if we wanted to put another point on our parabola, remember it's symmetric to this axis of symmetry, so I can see it's 2 places away from it. So if I went 2 places in this direction, my 6, and there would be another point. And then my parabola would look something like that. Okay, making sure that it's like a U-shaped at the bottom, not a V-shape. Okay. All right, well, I hope you found this helpful today in being able to go through some of these. And like I said, you know, I will be going through some other types of problems on the review that I'm going to do tonight also. So I highly suggest if you can come to it, do. It'll be from 7 to 9 p.m. And then I will record it also. Okay? What do you mean, Danielle? What version of the test is this? This is one from last year. It's actually not one of the ones that they show.
Go back and do the ones we missed.
Is that what you were wondering?
So to look for it, like, is it from 2018 or 19?
It's 2019, and I don't think they have it up there. So this was fall 2019. So, yeah, this is just a different one, but you can look at any of those and get a good idea, you know, of what you can do. So, I actually cannot send it out because the department has to decide. I said I can work through it here, but I can't send it out. So, but if you come to the review tonight or watch the review, we'll go through a few more things off of here and off of the review that will be really helpful for the exam. Okay?
Okay. So this isn't one of the examples that's on?
It's not. No. But,
okay.
yeah,
No,
but there's a lot of them on there that you can look through that are, you'll see are very similar to this. Okay? Yes, and the review will be recorded tonight.